Hello everyone, welcome back. Today, sorry, I forgot to introduce myself. My name is InsideXO. Yeah, it's my name. Today we are going to learn the linear equation and graphs. Yeah, I almost watched many of them before, 3 years ago or 5 years ago. I didn't remember that. Let's head into the introduction.
Pretty neat concept. Any value. What I'd like to introduce you to in this video is the idea of a linear equation. And just to start ourselves out, let's look at some examples of linear equations. So for example, the equation y is equal to 2x minus 3. This is a linear equation. Now, why do we call it a linear equation? Well, if you were to take the set of all of the xy pairs that satisfy this equation, and if you were to graph them on the coordinate plane, you would actually get a line. That's why it's called a linear equation. Let's actually feel good about that statement. Let's plot some of the xy pairs that satisfy this equation, and then feel good that it does indeed generate a line. So I'm just going to pick some x values that make it easy to calculate the corresponding y values. So if x is equal to 0, y is going to be 2 times 0 minus 3, which is negative 3. And on our coordinate plane here, we're going to move 0 in the x direction, 0 in the horizontal direction, and we're going to go down 3 in the vertical direction, in the y direction. So that's that point there. If x is equal to 1, what is y equal to? Well, 2 times 1 is 2 minus 3 is negative 1. So we move positive 1 in the x direction and negative 1 or down 1 in the y direction. Now let's see, if x is equal to 2, what is y? 2 times 2 is 4, minus 3 is 1. When x is equal to 2, y is equal to 1. And hopefully you're seeing now that if I were to keep going, and I encourage you to, if you want, pause the video, try x equals 3 or x equals negative 1 and keep going, you will see that this is going to generate a line. And in fact, let me connect these dots and you will see the line that I'm talking about. So let me see if I can draw. I'm going to use the line tool here. Try to connect the dots as neatly as I can. There you go. This line that I have just drawn, this is the graph. This is the graph of y is equal to 2x minus 3. So if you were to graph all of the xy pairs that satisfy this equation, you are going to get this line. And you might be saying, hey, wait, hold on, Sal. You just tried some particular points. Why don't I just get a bunch of points? How do I actually get a line? Well, I just tried over here, I just tried integer values of x, but you could try any value in between here. All of these, it's actually a pretty neat concept. Any value of x that you input into this, you find the corresponding value for y, it will sit on this line. So for example, if we were to take x is equal to, actually let's say x is equal to negative 0.5. So if x is equal to negative 0.5, if we look at the line when x is equal to negative 0.5, it looks like y is equal to negative 4. That looks like that sits on the line. Well, let's verify.
So he's talking about the linear equation. Oh, why people call this equation linear? Well, it's because the y will always change according to the value of x in a stable ratio. And if an equation satisfies this construction, if you draw this equation out, you'll get a perfect straight line. That's why people call it a linear equation, because in the end, if you draw it out, you'll get you will get a line. Let's have a look at the slope.
Slope is defined as your change in the vertical direction, and I could use the Greek letter delta. This little triangle here is the Greek letter delta. It means change in the vertical direction divided by change in the horizontal direction. That is the definition of slope, or the standard definition for slope, and it's a reasonable way for measuring how steep something is. So for example, if we're looking at the xy plane here, our change in the vertical direction is going to be a change in the y variable divided by change in the horizontal direction is going to be a change in the x variable. And so let's see why that is a good definition for slope. Well, I could draw something with a slope of 1. A slope of 1 might look something like, I could start it over here, and let me get my line tool out. So slope of 1, as x increases by 1, y increases by 1. As x increases by 1, y increases by 1. So slope of 1 is going to look like this. Notice, as I have a change in x, however much my change in x is, so for example here, my change in x is plus 2, is positive 2, I'm going to have the same change in y. My change in y is going to be plus 2. So my change in y divided by change in x is 2 divided by 2 is 1. So for this line, I have a slope. Slope is equal to 1. But what would a slope of 2 look like? Well, a slope of 2 should be steeper. And we could draw that. A slope of 2, I could start at that same point. Actually, why don't I start at the same point and we'll see. But you don't have to. Actually, let me start at a different point. So if I start over, let's say here, a slope of 2 would look like, for every 1 that I increase in the x direction, I'm going to increase 2 in the y direction. So it's going to look like, that. This line right over here, you see it. If my change in x is 1, change in x is equal to 1, my change in y is 2. So change in y over change in x is going to be 2 over 1. The slope here is 2. And now hopefully you're appreciating why this definition of slope is a good one. The higher the slope, the steeper it is. The faster it increases, the faster we increase in the vertical direction as we increase in the horizontal direction. Now what would a negative slope? Let's just think about what a line with a negative slope would mean. Well, a negative slope would mean that, well, we could take an example. If we have our change in y over change in x was, let's say it was equal to a -1. That means that if we have a change in x of 1, then in order to get -1 here, that means that our change in y would have to be equal to -1. So a line with a negative slope, a -1 slope would look like, let me see if I can draw it, would look like a -1 slope would look like this. Notice, as x increases by a certain amount, so our delta x here is 1, y decreases by that same amount instead of increasing. So now this is what we consider a downward sloping line. So change in y is equal to -1. So our change in y over change in x, change in y over change in x is equal to -1 over 1, which is equal to -1. So the slope of this line is -1. Now, if you had a slope with -2, it would decrease even faster. So a line with a slope of -2, it could look something like this. Let me draw it. So as x increases by 1, y would decrease by 2. As x increases by 1, y would decrease by 2. So it would look something like, it would look like that. Notice, as our x increases by a certain amount, our y decreases by twice as much.
Okay, from this graph, we at least know one thing. That is, if the absolute value of slope gets bigger, the more likely that line will be close to the vertical line, the center vertical line. And if that absolute value of slope getting to 0, then the line would be more likely to approach the center horizontal line right in here. Yeah, we could have a look at the introduction about the horizontal and the vertical lines.
What is the equation of the horizontal line through the point -4, 6? So let's just visualize this. Once you get the hang of it, you might not have to draw a graph, but for explanatory purposes, it might be useful. So -4, 6, that's going to be in the second quadrant. So if this is my x-axis, that is my y-axis. Let's see, I'm going to go -4 in the x direction. So 1, 2, 3, 4, -4, and then 1, 2, 3, 4, 5, 6 in the y direction. So the point that we care about is going to be right over there, -4, 6. And they're saying, what is the equation of the horizontal line? It is a horizontal line. So it's just going to go straight left, right like this. That is what the line would actually look like. So what is that equation? Well, for any x, y is going to be equal to 6. This is the equation, y is equal to 6. Doesn't matter what x you input here, you're going to get y equals 6. It just stays constant right over there. So the equation is y is equal to 6. Let's do another one of these. So here we are asked, what is the slope of the line y is equal to -4? So let's visualize it, and then in the future you might not have to draw it like this, but let's just draw our axes again. X-axis, y-axis, and the slope of the line y equals -4. So for whatever x you have, y is going to be -4. Let's say that's -4 right over there. And so the line is y. The line is y equals -4. So I can draw it like this. So what's the slope of that? Well, slope is change in y for given change in x. And here, no matter what I change my x, y doesn't change. It stays at -4. My change in y over change in x, it doesn't matter what my change in x is. My change in y is always going to be 0. It's constant. So the slope here is going to be equal to 0. Y doesn't change no matter how much you change x. Let's do another one of these.
Okay. That's fine. So here's another concept called x-intercepts and y-intercepts. Let's head into it.
The graph of the line 2y plus 3x equals 7 is given. Right over here, determine its x-intercept. So the x-intercept is the x value when y is equal to 0. Or it's the x value where our graph actually intersects the x-axis. Notice right over here, our y value is exactly 0. We're sitting on the x-axis. So let's think about what this x value must be. Well, just looking at it from just trying to eyeball a little bit, it looks like it's a little over 2. It's between 2 and 3. It looks like it's less than 2.5, but we don't know the exact value. So let's go turn to the equation to figure out the exact value. So we essentially have to figure out what x value when y is equal to 0 will have this equation be true. So we could just say 2 times 0 plus 3x is equal to 7. Well, 2 times 0 is just going to be 0. So we have 3x is equal to 7. And then we can divide both sides by 3 to solve for x. And we get x is equal to 7 over 3. Now, does that look like 7/3? Well, we just have to remind ourselves that 7 over 3 is the same thing as 6 over 3 plus 1 over 3. And 6 over 3 is 2. So this is the same thing as 2 and 1/3. Another way you could think about it is 3 goes into 7 2 times, and then you have a remainder of 1, so you still got to divide that 1 by 3. So it's 2 full times and then a 1/3. So this looks like 2 and 1/3, and so that's its x-intercept, 7/7. If I was doing this on the exercise on Khan Academy, it's always a little easier to type in the improper fraction, so I would put in 7/3.
All right, intercepts. In other words, it's just the concept of this is that the line, what's the value when a line across the y-axis, and for the x-intercept, it's a concept of what's the value of x when a line across the x-axis. Yeah, we're almost reached the end. We just have to watch one more video. Applying the intercepts and slope. Yeah. No matter what we know, in the end, the purpose for us is to use that kind of knowledge to solve real-life problems.
We're told Glenn drained the water from his baby's bathtub. The graph below shows the relationship between the amount of water left in the tub in liters and how much time had passed in minutes since Glenn started draining the tub. And then they ask us a few questions. How much water was in the tub when Glenn started draining? How much water drains every minute? Every 2 minutes? How long does it take for the tub to drain completely? Pause this video and see if you can answer any or all of these questions based on this graph right. All right, now let's do it together. Let's start with this first question. How much water was in the tub when Glenn started draining? So what we see here is when we're talking about when Glenn started draining, that would be at time t equals 0. So time t equals 0 is right over here. And then, so how much water is in the tub? It's right over there. And this point, when you're looking at a graph, often has a special label. If you view this as the y-axis, the vertical axis is the y-axis, and the horizontal axis is the x-axis. Although when you're measuring time, sometimes people will call it the t-axis. But for the sake of this video, let's call this the x-axis. This point at which you intersect the y-axis, that tells you what is y when x is 0. Or what is the water in the tub when time is 0. So this tells you, the y-intercept here tells you how much, in this case, how much water we started off with in the tub. And we can see it's 15 liters, if I'm reading that graph correct. How much water drains every minute? Every 2 minutes. Pause this video. How would you think about that? All right, so they're really asking about a rate. What's the rate at which water is draining every minute? So let's see if we can find 2 points on this graph that look pretty clear. So right over there at time 1 minute, looks like there's 12 liters in it and in the tub. And then at time 2 minutes, there's 9 liters. So it looks like as 1 minute passes, So we go plus 1 minute, plus 1 minute. What happens to the water in the tub? Well, it looks like the water in the tub goes down by, went from 12 liters to 9 liters. So negative 3 liters. And this is a line, so that should keep happening. So if we forward another plus 1 minute, we should go down another 3 liters, and that is exactly what is happening. So it looks like the tub is draining 3 liters per minute. So draining 3 liters per minute. And so if they say every 2 minutes, well, if you're doing 3 liters per every 1 minute, then you're going to do twice as much every 2 minutes. So 6 liters every 2 minutes. 2 minutes. But all of this, the second question, we were able to answer by looking at the slope. So in this context, y-intercept helped us figure out, well, where did we start off? The slope is telling us the rate at which the water, in this case, is changing. And then they ask us, how long does it take for the tub to drain completely? Pause this video and see if you can answer that. Well, the situation in which the tub has drained completely, that means that there's no water left in the tub. So that means that our y value, our water value, is down at 0, and that happens on the graph right over there. And this point where the graph intersects the x-axis, that's known as the x-intercept. And in this context, it says, hey, at what x value do we not have any of the y value left? Is there the water has run out? And we see that happens at an x value of 5, but that's giving us the time in minutes. So that happens at 5 minutes. 5 minutes, all of the water is drained. And that makes a lot of sense. If you have 15 liters and you're draining 3 liters every minute, it makes sense that it takes 5 minutes to drain all 15 liters.
Okay, it's just wonderful. So this is a basic math questions, and it's quite useful. And I believe in the real life, if you draw some water from a stump or from a tub, you still get the same result. It's probably a linear result. Yeah, we still have time. Let's head into another question.
Carl filled up the tank of his truck.
Oh, sorry, that's too annoying. Okay, so I guess that's today's learning, and inside of this video, we have learned about the concept of linear equation and also how it is applied to graphs and real-life problems. So I hope you enjoy this video, and I'll see you guys in the next one. Bye!